Okay, so this video is to explain you about the day one notes of scatter plots and relationships. So, let's this together. We want to introduce you the idea of scatter plots and to explain you the definition. A scatter plot is a graph that uses data points to show relationships between two variables, also known as bivariate data. What does it mean to have scatter plots and a bivariate data? Well, below here is an example of a scatter plot. There are three things that you should know when you observe a scatter plot in our topic. First is the data points. Like these points are called data points. That is a P. Data points like represent the total number of data, and it shows you how the data is a relation, what kind of relationships they have to each other. And the second is the independent variable. In this case, it is the x-axis. On x-axis on a scatter plot is called excuse me, my tablet is kind of wacky. Independent variable. Independent variable is a variable where it doesn't get affected by another example. It's just a individual variable that stays there, like a solo. But what about the y-axis? Like the number that represents the vertical line over here. That is called, again, the y-axis. But what is a different name for the scatter plot? It is called dependent variable. A dependent variable is a variable where it does get affected by the independent variable. As the independent variable changes, the dependent variable get affected by the independent variable. So it comes from the word actually. Independent variable is independent. It's just solo, while the dependent variable get affected by the another variable, so it's so dependent. So here, there are three terms that you guys have to know in this topic. First is data points, second is independent variable, and third is the dependent variable. Now let's move on to the types of relationships. Now we know that there is an independent variable and a dependent variable and the data points on a scatter plot. But like what kind of relationships can this of variables can show us? There are three types of relationships that we want to cover. And first one is called a positive. I'll highlight it. It's called a positive relationship. A positive relationship is, like, let me actually show you first before I explain you this. This is an example of a positive relationship. And this is another example that is also a positive relationship. The common thing that you students can observe is that, excuse me, is that as the independent variable increases, the dependent variable also increases. So it shows you a line, a linear that goes upwards. That is the definition of positive relationship. And also here, even though the data points are kind of scattered, not together, as the independent variable increases, the dependent variable slightly increases still. But as you see, there is a difference between these two positive scatter plots because the first one, the points are together, like they're very close to the positive line, and we call that strong. While the below one shows us a scattered, like the points are not together, they're kind of apart. So even though this is positive, we call this weak data. Now, we have talked about positive relationships, and now we want to move on to negative. And again, before definition, let me show you the example of negative correlation. Look at this. This is an example of a negative correlation or negative relationship. And this is another example that it can be a negative. Now, as you have seen, you should get the idea at this moment. This is called a negative relationship because as the independent variable increases, in the dependent variable decrease, it goes down. And that's the reason why it's called negative. And if you draw the line, you get a negative slope. This is also the point is scattered because it's a weak negative. But again, if the independent variable increases, the dependent variable decreases. So again, you can draw a line that shows you the negative slope. And what do you think the difference between these two are? The first one, the data points are close to the line, therefore it is a strong data. But the second example, again, the data points are far away from the line, therefore this is a weak data. Now, we have talked about positive relationships and negative relationships about data, but what about, what does a none, what does it mean to have a no relationship? Let me show you the example again. Here, this is an example of a none relationship, like there's no relationship. You see there is no pattern between the independent variable and the dependent variable. Like there is no relationship over here. The data is just scattered all over the place without any rules. Therefore, this does not show relationship. Therefore, this is a no or like non-relationship. So we went over 3 relationships here, and let's move on to the next page. Now that we have talked about relationships, we want to be much more professional, not just using the word relationship. The relationship between two variables can be called as a different name, and we call that correlation. And in math, we use the word R, not C. We use the word R because C stands for constant. We use the word letter R in math to represent the correlation. So I have 3 examples that shows you the correlation of the data in number. Here, you see that this data is again a strong, because the points are close to the line, and because it's decreasing, it's a strong negative correlation. As the data is strong negative, look at the correlation value, the number. What does the number equal to? The number equals -1. And here is the trick. As the R value is close to -1 or 1, it is a strong data. But if the data is close to 0 instead, it is a weak data. This is just a highlight to show you an idea what the numbers mean. And because this R value over here that Mr. T have highlighted is very close to -1, therefore it's a strong data, and because it's decreasing, it's a strong negative data. By having that in mind, let's look at the second example. The correlation number is 1. And what did I told you if the data is close to -1 or 1? It is a strong data. And because it is increasing, it's strong positive data. Okay, then what about third example? The R value is 0. And what did I told you? If the R is close to 0, that it is a very, very weak data, and as the data gets weaker and weaker, it eventually shows you no correlation, therefore none. This is how you can use the R value to identify the strong or weak relationships of a data. And here it is. There is a sentence that summarizes everything I showed you. The closer to 1 or -1, the stronger the correlation. As I have showed you over here, let me use a color to identify where it's coming from. As the data, this is the number line that Mr. T drew. The close to 1 or -1, the stronger the correlation. The farther away from -1 or 1, like 1 or -1, my bad, the weaker the correlation. So in other words, if your data is far away, that means closer to 0, it is a weak data. Have that in mind. That is the takeaway from today's notes. I'll put a star on this information. This is going to be on the SOL. Now, let's talk about some example questions. You guys can stop this video for a moment and do the questions by yourself. And I will show you the answer. This is a none because it shows no relationship. The second example is a negative, but it's enough strong. If you look at the line, the points are together. This is an example of a positive, but you see that the points are kind of scattered, so it should be weak. Here, this data is a positive data, it's strong enough. And here, this data is negative, and it is also strong enough. And this data, as you can see, it doesn't even have a line, so it's a none. Actually, before I move on, I made a mistake. This data, my bad, it should be a weak data. My bad. The points are kind of like far away. So if you got the same answer as Mr. T did, then congratulations, you have understood correlation. Now let's move on to our last page that shows some example of a SOL question. Reading is very important in statistics questions, so please read carefully, highlight the words as you read on. So let's read together. Question 1. Ryan surveyed his peers at school to see how many hours they spent on their phones and how many hours they spent on schoolwork. And Ryan has created the following scatter plot. And if you look at the first question, how many peers did Ryan survey? Like how many peers did he survey? Here, you guys can simply count the number of points because those points refer to the number of people he surveyed. So 1, 2, 3, 4, 5, 6, 7, 8, 9. He has surveyed 9 people. And what is the relationship between the data? The relationship is asking you if the data is a positive correlation or negative correlation, or either like neither one. But if you see the line, it's showing you a negative slope as you make a line that fits best the data points. And because it's decreasing, we can say it has a negative relationship. The third question is what you guys should highlight, and I'll put a star before I move on. Describe the relationship using words. Yes, in statistics, you are going to be tested if you are able to describe your answer in a sentence. And here's the Mr. T trick. First, always highlight the independent variable and the dependent variable. Why? Because those independent and dependent variables shows you it will help you to describe the relationship using words. And here's the Mr. T trick. First, write down the independent variable. In this case, it's hours spent on phone. Hours spent on phone. Okay, hours spent on phone. And what kind of relationship does this data shows you? We already answered in the question above. The hours spent on phone shows you what kind of relationship? Negative relationship. So I will write hours spent on phone has negative Instead of word, actually, I'll use the word relationship. Who cares? It's correct. Relationship to, and which variable is affected, like dependent by the independent variable? The dependent variable. That's the reason why it's called dependent variable. And I'm just gonna write the word by word. In this case, it's going to be hours spent on schoolwork. So here's a Mr.T trick to summarize it. First, write down the independent variable, which is solo, in this case, hours spent on phone, and write down the relationship that the data is showing you. In this case, it's a negative relationship, so has negative relationship to, and write down which variable get affected by the independent variable. In this case, dependent variable, hours spent on schoolwork. So if I just read my sentence, I can say hours spent on phone has negative relationship to hours spent on schoolwork. Now, let's move on to the next one. What is a good guess for how many hours someone spends on their schoolwork if they spent, let me highlight this, spent 9 hours on their phone. So it's just asking you to estimate if the student have like used 9 hours on phone, what is the estimated hours spent on schoolwork? Like how can you predict the future? It feels like impossible. But by the power of scatter plots, we can actually predict it. Here, 9 hours spent on their phone is the independent variable. So I'm just gonna find the number 9. So that is 9 hours spent on phone. And as the hours spent on phone equals 9, what is my approximate value? When you spent 9 hours on phone, the estimated hours spent on schoolwork should be correlated on this line. So if you actually look at it, as you spend 9 hours on phone, your estimated hours spent on schoolwork should be between 2 to 4 hours by the line, the negative slope. So I can write my answer as between 2 to 4 hours. So this is a first example of a SOL question that uses scatter plots. We have 2 more examples to go, and let's go. Again, read the question. The scatter plot below shows the relationship between the number of cups of coffee consumed and in the morning, and I have to highlight in the morning, and the exam grade taken later that same day. Here, what is the relationship between this data? Like, look at the data and check if this is positive, negative, or no correlation. Here, the data is scattered everywhere, chaotic, therefore it has no correlation or none. Then you think, oh, then I'm done. There is no correlation, so there is nothing more to ask me. Well, there is. The SOL question will ask you anything if they could, and look at those 3 questions. What is the x value of point A? Where is point A? Here it is. This is point A. And what is the x of this point? What is the x value of this point? It is 1. So I can write 1. What is the next question is asking you? What is the y value of point A? What is the y value of point A? 50. And what does this point mean in context of your data? Now we have to write what this number 1 and number 50 means in context, and always read the question, identify the independent and the dependent variable. The X stands for cups of coffee and the Y stands for exam grade. So I can write that 1 cup of coffee, because that is the independent variable, 1 cup of coffee 1 cup of coffee gave you 50 exam grade. So in context by vocabulary and grammar, I can say 1 cup of coffee maybe resulted, that's a good word, resulted in 50 exam grade. So even though the relationship is none, it can still ask you multiple questions like what is the x and the y value of a data point and what does that mean in a context. So always highlight that. Always look at the graph because the graph always has all the answer. Now let's move on to the last example. The scatter plot below shows the relationship between the temperature outside and the number of popsicle sales. And it's asking you, what is the relationship between this data? If you look at the data, it is increasing, therefore it is positive. And let's describe the relationship using words. And what did I told you? Always write down the independent variable first. It's the same example that Mr. T did over here, the star question. I'm gonna do it in the same order. My independent variable is temperature, so I'm gonna write temperature. Temperature is, what is the correlation? The relationship is positive relationship. To, what is my dependent variable? Popsicle sales. So I can say temperature is positive relationship to popsicle sales. Again, write in order, independent variable, the relationship, and the dependent variable. Just have the order inside your head, and as you get used to it, it should be no problem. Let's move on to the third question. What is the unit of the measure? This is what lots of students get confused on the SOL. So I'm going to highlight it. What is the unit of the measure of the independent variable? Again, my independent variable is temperature. Oh, let me erase some lines. It's kind of messy. The independent variable is again temperature and asking you for the unit. Unit is just a term, a word that describes what the number means on a data or in real life. For example, all these x value numbers represents temperature. But what kind of temperature? Fahrenheit. If you look at the alphabet inside the parentheses right here. So I'm going to put a star. Those always represent the unit of the measurement. And in this case, it's going to be Fahrenheit. So I can just copy that notation Fahrenheit. What is the next question is asking you? What is the unit of the dependent variable? And what is my dependent variable in this case? Let me erase the messy part. My dependent variable is popsicle sales. And what is the unit, the value inside the parentheses? Dollar. So the unit of my dependent variable is dollars. That is end of the day one notes. If you have missed the class, please work on this practice. The PDF file should be available in Schoology. And I think that is end of the video. If maybe I'll see you guys in day two notes.